Welcome to Asterisk, the timeless forgotten mystery star. Earth, our home, a tiny blue dot drifting in the vast cosmic ocean. Here lives everyone you've ever known, every human who has ever walked this planet, every story ever told. It's where our journey begins. But as we pull back, past the atmosphere, beyond the moon, the familiar planets, and even the sun, we embark on an extraordinary quest to truly understand the scale of our universe. The first stop on this cosmic voyage is the moon, about 384,000 kilometers away. That's such a massive distance that driving there non-stop at 100 kilometers per hour would take over 160 days. From the lunar surface, Earth appears as a delicate sphere of blue and green, suspended in the endless darkness, a sight that instantly puts our existence into perspective. Moving onward, our next milestone is the Sun, roughly 1 astronomical unit from Earth, or about 150 million kilometers. This distance is the standard measure for our solar system. Light, racing at 300,000 kilometers per second, still needs 8 minutes and 20 seconds to reach us from the Sun. But if you tried covering that distance in a commercial jet flying at 900 kilometers per hour, it would take you nearly 19 years. Even within our solar system, distances are staggering. Yet from this incredible range, the Sun fuels life on Earth with its boundless energy. Beyond Earth and the Sun lies Mars, our mysterious red neighbor. At its closest, Mars is about 54.6 million kilometers away, but that gap can stretch to 401 million when the planets drift apart on opposite sides of the Sun. At jet speed, such a journey would last more than 50 years. These vast distances have always challenged space exploration. Every rover and probe we've sent to Mars has faced the complexities of shifting orbits and astronomical scales. Farther still is Neptune, the distant ice giant, 4.5 billion kilometers from Earth. Here, sunlight takes 4 hours and 15 minutes to arrive from the Sun. Neptune marks the edge of our solar neighborhood, a boundary that emphasizes just how massive our system truly is. In 1977, Voyager 1 was launched to push beyond those limits. For more than 40 years, it has been traveling across the cosmos, now over 22 billion kilometers from Earth, the farthest human-made object in existence. In 1990, at the suggestion of Carl Sagan, Voyager 1 turned its camera back for one final image. What it captured was the legendary pale blue dot, our planet, seen from 6 billion kilometers away, reduced to a single faint pixel. Sagan's reflection on that image reminded us of our duty to protect this fragile home, the only one we've ever known. At the very edge of our solar system lies the Oort Cloud, a vast, theoretical sphere of icy remnants extending nearly 100,000 astronomical units, or about 1.9 light years. This is where the Sun's influence fades into interstellar space. Scientists call this boundary the heliopause, where the solar wind surrenders to the interstellar medium. Beyond it, the great unknown begins. Our next stop is Alpha Centauri, the closest star system, around 41.3 trillion kilometers away, about 4.4 light years. To put this into perspective, even traveling at Voyager speed of 17 kilometers per second, it would take more than 70,000 years to arrive. Such unimaginable distances highlight the nearly impossible challenge of interstellar travel. From there, we zoom out to our galactic home, the Milky Way, a spiral galaxy stretching 100,000 light years across, containing hundreds of billions of stars, many with their own worlds. Within this immensity lies the human radio bubble, a sphere just 100 light years wide, the reach of our earliest broadcasts. Beyond it, humanity is invisible. To most of the galaxy, we do not yet exist. Leaving our galaxy, we step into the immense silence of intergalactic space. The Milky Way belongs to a small family of galaxies called the Local Group, over 50 galaxies spanning 10 million light years. Among them are giants like Andromeda, as well as numerous smaller dwarf galaxies. Light itself would take 10 million years to cross this cluster, dwarfing all distances we've considered so far. Further still, we encounter the Virgo Supercluster, an enormous collection of galaxies stretching 110 million light years across and containing thousands of galaxies. But this too is just part of something greater. That greater structure is Laniakea, the immense heaven. Extending more than 500 million light years, it includes the Virgo Supercluster and countless others, bound together in a cosmic web of gravity. At its heart lies the mysterious Great Attractor, a hidden force pulling galaxies across the vast expanse. Within Laniakea, our Milky Way, the Local Group, even the Virgo Supercluster, are mere tiny threads in an unimaginable tapestry. Finally, we reach the edge of the observable universe, a sphere 93 billion light years across. Yet the universe itself is only 13.8 billion years old. How can that be? Because space itself is expanding, stretching faster than light, pushing parts of the cosmos forever beyond our reach. What lies beyond the observable universe? We may never know. It could be infinite. And so, we are left with a profound realization. For all our exploration, all our discoveries, the vast majority of the universe will forever remain unseen, its galaxies, stars, and wonders receding endlessly into the depths of eternity. Thank you for watch *, the timeless forgotten mysteries *.